everyone, it's Justin again. In this lesson, you're going to learn about the distance formula. It's great for telling us, well, the distance between 2 points. We'll go over the basics of the distance formula in this lesson, and then in the next lesson, you'll learn how to deal with answers that aren't such nice numbers. By the end of this lesson, you should be able to use the distance formula to find the length of a line segment. First, you'll learn how the distance formula is related to the Pythagorean theorem. Then we'll complete 2 practice problems using what we just learned. In our previous lesson, we got to practice using the Pythagorean theorem, and now it's really going to pay off. From the Pythagorean theorem, we're going to create the distance formula. Here's the Pythagorean theorem as we know it and love it. But what if I don't want the equation set up to give me the hypotenuse squared? What if I want the equation set up just to give me the hypotenuse, no extra solving involved? We can solve for the hypotenuse of a right triangle, or C value, in one step. All we have to do to get C by itself is take the square root of both sides of the equation. Then we may as well switch around the 2 sides of the equation so the variable we isolated is on the left. Now, let's think about what this formula really represents. In a right triangle, this formula tells us the value of C, or the hypotenuse. Another way to think about this is that it's the distance between these 2 points. Remember this triangle from the previous lesson? It had legs with lengths of 5 units and 12 units. And when we plug those in for A and B, we can solve to get that the length of C, or the distance between the 2 points, is 13 units. We say units to represent length if it wasn't specified what type of units we're working with, like centimeters or meters or inches or whatever. Anyways, what if you aren't given the entire triangle? You were only given 2 points. We could draw those points on a coordinate plane and then draw a right triangle and count to see how long the legs are. Then we would just use the Pythagorean theorem again, like we did before, and we'll know the distance between the 2 points. But that's honestly more work than it needs to be. Plus, what if your side lengths are like 1,245? There's no way we're finding enough graph paper to draw that. So, I have a question for you. What do you get if you subtract one of these x values from the other? If you chose to do 2 minus -3, you should be thinking 5 right now, since subtracting a negative number is the same as adding. And if you chose to do -3 minus 2, you should be thinking -5. Either way, positive 5 squared and negative 5 squared both take us to 25 and represent this part of our equation. Another way to think about this is that the x values here match. And since we're trying to find this horizontal distance, it's the difference between the x values that we really cared about. I want you to have some time to explore this more. So, can you figure out how the y values of the points are related to this part of the equation? Pause the video and try to figure out what's going on here. We can subtract the y values in either order. You could choose to start with 7 and subtract -5. Remember, subtracting a negative is the same as adding, so this would give you 12. And 12 squared is 144. If instead you chose to start with -5 and subtract 7, you would then get -12. And -12 squared is also 144. What we've just figured out is a way to use the Pythagorean theorem without needing to draw a triangle, and without a coordinate plane. Now, if we represent these points in a general way, we can make the distance formula. So let's call these points x1, y1, and x2, y2. Or remember how I told you the order we subtract in didn't matter? Well, that's still true because we can switch where we label these points and still end up with the same answer. The difference between the x values is what we'll use to replace a in the Pythagorean theorem. And the difference between the y values is what we replaced b with. And this gives us the distance formula. We did it. We found the distance formula directly from the Pythagorean theorem. This is our shortcut. We won't have to rely on drawing triangles on a coordinate plane any longer. Next, we're going to do some example problems, but there is space on your notes template to summarize what I just showed you. So pause the video now and give yourself all the time you need to summarize our findings on your notes template. Go back and rewatch parts of the video too, if it'll help you. Let's try a problem. Can you find the distance between the points -4, 5 and 2, -3? Pause the video and see how far you can get. All right, let's see how it went. When calculating x2 minus x1, did you get either -6 or +6? It doesn't matter which, because when we plug it in here and square it, it's going to turn into 36 either way. I'm going to write -6. Then I can square it and write 36. Now we can move on to the y values. Subtract the y values in either order. I'm going to go with 5 minus -3 and use 8 in my equation. But you could use -8 too, because when we square 8 or -8, we will get 64. Then we can finish solving like we normally would. Add the numbers together and take the square root. This gives us a final answer of 10 units. Don't forget to label your distance with units, unless you're given a more specific type of measurement in the problem, like centimeters or inches. Let me prove to you that this is the right answer. Here's a coordinate plane with the 2 points on it. We can draw a right triangle and see that the legs are 8 units long and 6 units long. 6 squared is 36 and 8 squared is 64, just like we had in our formula. And our formula told us that the hypotenuse of this triangle is 10 units. Let's do one more problem. And I actually want to give you another option for how to approach these kinds of problems. I want us to label our points using x1, y1, and x2, y2. This is the first option for labeling them. And here's the other option. Let's stick with this labeling option so we all have the same work as each other. Pause the video here and try to substitute these numbers in to find the distance between them. Did you substitute in 1 for x2? Did you substitute -2 for x1? How about 3 for y2? And finally, -1 for y1. Then we could continue like we normally would. 1 minus -2 is 3. And 3 minus -1 is 4. Then we square both numbers, add them together, and take the square root. This gives us our answer of 5 units. We can even check our answer with a drawing and see that we have a 3, 4, 5 triangle, and that the distance between the 2 points is indeed 5 units. We definitely won't be able to use a drawing when the numbers get really big, but for now, you can use a drawing to check your work. Anyways, that's it. We have our answer. Now you know how to use the distance formula. In the next lesson, we're going to continue to practice the distance formula when there are more difficult numbers involved. See you next time.
Hey, hey.